So we have, let's just draw this snowball. I'll draw it as a rectangle. It doesn't really matter. It's just some mass. And then we have a force normal perpendicular to the surface of the incline, force of friction opposite of the direction of motion, which is down the incline, and then force of gravity, and theta. So we need to first apply the sum of forces in the x and y direction. However, this block of this snowball is at rest. So we can say that sigma F in the y direction equals 0 newtons, and this will equal a force normal minus the y component of gravity, so mg cosine of theta. Now, we can then infer that the normal force is equaling mg cosine of theta, and we can say that sigma F in the x direction is equaling force of friction minus mg sine of theta. So here, force of friction is actually allowing you to stay on the incline, and the x component of gravity is what's trying to quote unquote bring you down, essentially. So here we know that force of friction is going to be equal to mu s mg. This will equal 0 as well. So we can say mg cosine of theta, because again, force of friction simply equals the coefficient of static friction times the normal force. So simply mu sub s times mg cosine of theta. But this is also going to equal mg sine of theta, because again, there isn't any motion in the x or y directions. So we can say that the m's cancel out, g cancel out, and we're simply saying that mu s, this coefficient of static friction, equals tangent of the angle, and this is going to be tangent of 34 degrees, and this is equaling 0.67. So if mu sub s is greater than 0.67, that means that there is no possibility of this slipping down the hill. If it's less, there is a possibility. Now, part B asks us here, now it is sliding down. When it's sliding down, it's not as if the free body diagram changes in any way. The force of friction still is in the same direction, because again, we're still sliding down the incline. But here now, f of n still equals mg cosine of theta, because there isn't any motion in the y-axis. That's how we're defining our Cartesian axes. And then we can just reapply the same formula. The sum of forces in the x direction equals mg sine of theta. Now the x component of gravity is positive, because we're moving down the incline, and what's stopping us is force of friction. So it'll be minus force of friction now. And this equals ma sub x. We can say mg sine of theta minus mu sub k mg cosine of theta equals ma sub x. The m's cancel out, so mass cancels out, and a sub x should equal g sine of theta minus mu k cosine of theta. We know that the final velocity equals the square root of 2 times a delta x. So we can say that this is going to be equal to radical 2g delta x sine of theta minus mu k cosine of theta. And so we can say that final velocity equals 2 times 9.8 times 4 meters, and then here it'd be sine of 34 degrees minus 0.1 cosine of 34 degrees, and this is equaling 6.11 meters per second. So this will be our final velocity at the end of the incline. That is the end of the solution. Thank you for watching.